Good morning, sir.
Good morning. Do you have any doubts from the units and dimensions chapter? From anything which we have read till now?
So,
Okay, so let us start vectors and scalars. So the scalar quantity has, so these are the differences. Scalar is having only magnitude, no direction. Vector has both of them. For addition, we have vector law of addition applicable for vectors. For scalars, it's normal rule of algebra. Scalar quantity can change in terms of magnitude. Vector can change in both. Resultant of two scalars is scalars. Resultant of two vectors can either be a scalar or a vector. Like especially the dot product of two vector quantities gives a scalar quantity. Examples are there. Now, since vector is having both magnitude and direction, so therefore a convenient way to represent it is using an arrow. The length of the arrow gives the magnitude, and the direction of the arrow gives the direction of the vector. This is the vector rotation. Now it's relative in the sense means like if 10 Newton is this, then 5 Newton is going to be half of 10 Newton and the sense of direction remaining the same. Angle between two vectors. So both the vectors are drawn from one point in such a manner that the arrows of both the vectors are outwards from the point. That means when it is asked that find out the angle between two vectors, then we have to join the tail of both the vectors and then find the angle between them. Okay. Now the smaller angle is called the angle between two vectors, and the smaller angle should be in between 0 to 180 degrees. So here in this case, the angle between A and B is not 120 degree, it's 60 degrees. Is it clear? Hello. Good. Find out the angle between A and B. Message in the what the Zoom chat. Second one is 150. Because that should be, the tail should be same. Is it clear? Find this. So a and minus 3 upon 2a. So a, we take any general, any random direction. This is a. Then minus 3 by 2a must be in this direction. Now, both the tails have to be joined together. So we join both the tails together. Now the angle is going to be 180 degrees. Is it clear? If yes, please raise your hand. Good. Different types of vectors. Zero vector, null vector. Does it has zero magnitude, no specific direction. Unit vector. The magnitude of the unit vector is going to be 1. Equal vector. Both have to be equal. Magnitude also, direction also. Parallel vector. The direction has to be same. Magnitude can be different. Anti-parallel. The direction has to be opposite. 180 degree opposite to one of them. And magnitude can be anything. Negative vector, magnitude has to be 100% equal, but the direction has to be opposite. Concurrent, all of them, their, the tail should match, or in one sense, like all of them should meet at a point. Coplanar, lying in the same plane, that's going to be coplanar. Orthogonal, 90 degrees, or orthogonal or perpendicular vectors. Now, multiplication and division of vectors by scalars. So if we have a, then 2a will be just, we have to multiply the magnitude by 2. Okay, so this is first pivot. Any questions in the introduction to vectors? If you have any questions, please ask. Is everything clear till now, whatever we have discussed? Good. Okay, addition of vectors. That's the parallelogram law of addition. So we have a vector plus b vector. That's what we want to find out. So as we can see here, this is a vector, this is b vector, and this is going to be a vector plus v vector. So what we have to do is, on the head of the a vector, we add the we place the tail of b vector, and then finally the tail of a vector and the head of b vector, they are joined together. That becomes a plus b vector. Now, how to find the magnitude and the direction of the a plus b vector? So if we see the triangle ADE, okay, so in this triangle, the leg is A and D, and the hypotenuse gives us, the length of the hypotenuse gives us the magnitude of the A vector plus B vector. Now, this B vector is resolved as B cos theta and B sin theta. So therefore, AD square, or the hypotenuse square, like we use the Pythagoras theorem, and we get A plus B cos theta, because this was A. So A plus B cos theta, this entire A square plus D square is going to be AD square, which is A vector plus B vector. So therefore, we add here plus B sin theta whole square. Is it clear? If yes, please raise your hand. Good. So that's how we find the magnitude, a root a square plus b square plus 2ab cos theta. And we find the angle also by that. Tan alpha is equal to b sin theta divided by a plus b cos theta. There shouldn't be any confusion in this. Okay, so now here if you see p and q are given, we have to find r vector. So this q vector, we take the tail of it and place it on the head of P. That's what we have done. And then we have found uh, R vector, which is P plus Q. So that's so actually, the principle wise, it's same only parallelogram law or the triangle. So parallelogram law tells that when you have two vectors, then the two adjacent sides, you draw both of them and complete the parallelogram. The diagonal is going to be the addition vector. In triangle law, it's stated that the adjacent sides are a vector and b vector, and the third side becomes a vector plus b vector. The polygon law states that, so this is a vector, this is b vector, this is a plus b vector. Now on this a plus b vector, we add c vector, so this is a plus b plus c vector. Now on this a plus b plus c vector, we add d vector, so it's a plus b plus c plus d vector. Like that, we can keep on adding ahead. Does it make sense till now, everything? Please raise your hand if yes. Good. Find this. You have to give the answer in terms of capital A and theta. Direction. So similar question was asked in JEE Mains. Do this. Of course, like we haven't studied subtraction. Yes. So it's going to be C. Yes, option C. Just see how we have done it. If it is clear, please raise your hand. Then we shall proceed ahead. Gauri, is it clear?
If they're having equal magnitude r, so why did we take 2r square and
So if A is like
a plus b? Okay. Yeah.
A is R, B is R. That's why it. Is it clear?
Shouldn't it be just R square? Because,
So r square plus r square is 2r square. And
okay,
here
okay,
already it's 2 there. So 2r into r. So
right,
again it's 2r square. Okay.
okay, right. Yeah, thank you.
Okay, we proceed ahead. Solve this. Yes, it is C. Sujita, is it clear? Yes. If it is clear, can you raise your hand? Shall we proceed ahead? Any doubt, Sujita? No. A vector in xy plane makes an angle of 30 degree with the y-axis. So this with the y-axis, it's 30 degrees. The magnitude of y component of the vector is 2 root 3. Okay. So let it be, r. So we have r cos 30 degree is 2 root 3. So that means r root 3 by 2 is 2 root 3. Gone, gone. So therefore r is 4. Now they want to they are asking us x component of the vector. So x component of the vector is going to be, so this is going to be 60 degree. So r cos 60 degree, which is 4 into 1 by 2, which is 2. Is it clear? Okay. Solve this. Good, it is B. Okay, we proceed here. And here the angle was theta by 2. Angle also had to be found out. So it's going to be a sine theta divided by a plus a cos theta. Just see if this is clear to you. If it's clear, kindly raise your hand. Okay, good. Okay, so here we can see that addition of two vectors gives us a third vector, which is like um, different than the scalar addition. Scalar addition of 3 plus 4 is going to be 7, but then the vector sum is going to be 5. Okay, now just to mention here, current is a tensor quantity. It has direction, but the vector law of addition doesn't apply to it. Why? Because imagine, like the current which is entering here is 3 ampere, 4 ampere. The current which comes out of it, so we have read the Kirchhoff's junction law. Current coming inside a junction is going to be the total current which is going outside the junction. So here it must be 7 ampere. Now here we don't tell, okay, this is 3, this is 4, so it's perpendicular, so therefore it should be 5 ampere. No, it's 7 ampere. So vector law of addition doesn't get applied to it. Okay, so therefore current becomes a tensor quantity. Does it make sense? Yes or no? Suchit, is it clear? Is it clear, both of you? Please raise your hand. Wasn't able to see. So you see, we'll be, coming across, such formulas, IL cross B, the force on a current carrying conductor. So if you see, this is the conductor and this is the current. Now, when we have L vector associated with it, now this L vector is basically the direction of current determines the direction of L vector. So that means current has direction. But the vector law of addition doesn't apply to the current. So current is having both magnitude and direction. But since vector law of addition is not applied to it, so therefore current is a tensor quantity. And if it is asked, if there are only two options given to us, vector or scalar, then we have to choose scalar. Is it clear? If yes, please do. Okay, we proceed ahead. Subtraction. So in subtraction, what we have to do? Like a minus b is there. So that is equal to a plus minus b. So what we have done is we have just reversed b. So we have done the negative of b, which is here. And then we find out a minus b, which comes out to be this. Solve this. Sir, what is tensor quantity? I explained it. Is it clear to you? Sujata? Tensor quantity, it has magnitude and direction, but the vector law of addition doesn't get applied. So therefore, it doesn't qualify a vector also, and neither it is completely scalar. Solve this. What's the magnitude? Both of them. Yes. So for addition, it's a square root 37, and the angle is going to be 25.3 degrees. Just see this diagram. If it is clear, please raise your hand. If it's clear, please raise it. Is it clear, Sachita? Is it clear for you? Addition thing. Now this is subtraction. Root 13 is correct. The angle is 46.1 degrees, and that's in the negative direction. Okay, got it. Solve this. Okay. This is going to be 5 root 3 and 5. Yes, good. Now these are the components of vector. A vector has its component as a sine theta and a cos theta in the perpendicular and in the like base. If it is making an angle theta with the base axis. Okay. For 3D, we have to add the z vector also. Okay. like in the k direction. Now, this is very important. The angle which is made by the vector with the x-axis is going to be cos inverse rx divided by ry divided by z divided by r, respectively, with the x, y, and z axis. This has to be kept in mind, and we have to be very clear about this. If you want, you can take a screenshot of this. If it is clear, we proceed ahead. Please raise your hand if it's clear. Good. Solve this. And one more thing, like 37 degree, 53 degree, we should know, sine and cos. If you know, please raise them. Along with 30, 60, 45. 37 and 53. Don't know? Yes. Just for your reference. And you should remember this. Perfect. All this. Write it in terms of cos inverse and some like number. And it will be cos inverse of that. Is it clear? Yes, Gauri. Okay. So this is the one. Cos inverse 12 by 13 minus 3 over 13 and minus 4 over 13. Okay. So this addition subtraction is done. We proceed ahead. dot product of vectors. So addition done, subtraction, now multiplication. There are two types of multiplication which can happen. So the first one is scalar or dot product. As the name suggests, the scalar or dot product will have output as scalar. Okay. So now when the output is a scalar, that means we have to be worried only about magnitude, as scalar quantity doesn't have any direction. So now the magnitude is given by magnitude of A, magnitude of B multiplied by cos theta. Is it clear? The definition? Okay. Now theta is of course the angle between both of them. Now these are some properties. A dot B is going to be equal to B dot A. A dot B plus C is going to be A dot B plus A dot C. A dot A is going to be A, like mod A into cos theta. Theta is going to be 0 degree because it's the 0 degree is the angle between A and A. So therefore that becomes A square. And the fourth point is very interesting. Say A dot B is AB cos theta, or we can write it out as A multiplied by component of B along A. So like for example, A is like this, B is this. So the component of B along A is going to be B cos theta. So therefore AB cos theta. Or we can even write it as, so this is B, this is A, this is theta. So even A can be resolved as, in this direction, A cos theta and A sin theta. So, or else we can even resolve A as A cos theta and A sin theta. A cos theta is along B and A sin theta is perpendicular to B. So therefore, both the ways it's going to be correct. Okay, either we can do A multiplied by component of B along A, or B multiplied by component of A along B. Does it make sense? Okay. Fifth point, I dot I, J dot J, K dot K is basically magnitude of I and J and K cap vector is 1 only. So therefore, it's going to be 1 into cos 0, which is 1. Now I dot J, J dot K dot I is going to be 0 because the angle between all of them is going to be 90 degree. Seventh point is again interesting. So A1I plus B1J plus C1K. Okay. So I will just do for A1I cap. So A1I cap dot A2I cap plus A1I cap dot B2J cap plus A1K cap. Oh, sorry. A1I cap dot C2K cap. So I dot K is 0. I dot J is 0. So what is remaining is only I dot I, which is A1 into A2. Similarly, when we multiply B, is going to be B1, B2. C is going to be C1, C2. So ultimately, all the respective values in their coordinates, okay, those components, they get multiplied, and ultimately all of them, they get added. If it is clear, please raise your hand. We will see few examples, things will become clearer. But till now, if you don't have any doubt, okay. Eighth one and ninth one, these two properties are very much used many a times. Okay, so if we have to find the angle between two vectors, we use cos theta A dot B divided by AB. And the ninth is when we use when two vectors are perpendicular, their dot product is going to be 0. Now here I would like to state one very important thing. See this eighth one. See, we can write even this also, no? Sine theta is going to be A cross B divided by mod A mod B. But we don't write that. Instead, we write only cos theta equals mod A equals A dot B divided by mod A mod B. So why we don't write for sine theta? Why we write for cos theta? The angle between two vectors. Can you tell? Sine theta, there will be cross product. That's correct. So sine, so like A cross B is mod A mod B sine theta. So we can write now theta is equal to sine inverse A cross B divided by mod A mod B. But this is not written. This is not used to find the angle between two vectors. Can you tell why? Okay, so I'll tell you. So if you see, angle between two vectors will be between 0 and 180 degrees. Right? Yes or no? Yes, if you raise your hand. Raise your hand. Angle between two vectors can never be 240 degree because it's going to be the smaller angle between two. Yes, Suchita, you are close. You are close. You are close. So basically, what happens is that sine theta from 0 to 180 is like this. Cos theta between 0 to 180 is like this. So if so, you see, if sine theta, like we get something as theta, we cannot tell whether the angle is, let us say, we get 1 by 2. So the angle between two vectors can be 30 also, it can be 150 also. It's not giving us unique value. Whereas cos theta is going to give us unique value. Okay. Like if it is, see, it is unique between 0 to 180, it's all unique only. Does it make sense? Yes or no? If yes, please raise it. Good. We proceed. Solve this. Minus 8 June. 28 minus 8. Just see the calculation. If it's clear, please raise it.
But isn't it? Oh, never mind. I wrote it wrong. Never mind.
Okay, displacement vector is the final position minus the initial position. Okay. Why is it so? So this is, let us say, this is the initial position, this is the final position. This is A, this is B. Now we have to find AB vector. So we can see very clearly OB vector is equal to OA vector plus AB vector. Now AB vector is OB minus OA, which is the final vector minus the initial vector, not the other way. Does it make sense? If like that's where like this is a okay. Does it make sense? Maybe that was the issue with you. Okay, we proceed. Solve this. There will be no I and K, Corey, because the cross product will give us vector, but dot product we won't give us vector. It's just going to be 2 plus 1, which is 3.
Noted, yes, sir.
So A dot B, that becomes 3. Mod A, root 6, mod B, root 2. So A dot B divided by mod A, mod B. That's cos theta. So cos theta is root 3 over 2. So therefore theta is 30 degrees. Okay. Here, one thing I just want to tell, like this state here. You see, A vector and B vector are given. An angle between both angle and 30-degree angle is like very, it's very pleasing, when we get 30-degree, 45-degree, 60-degree, such answers. But if you see here, since it is like K, 3 dimensions, therefore, just by seeing that, it's very difficult to make it out. So once we are well equipped and we have well understood and we are well trained to use the formulas, better is to rely on the formulas, okay, than just feelings. Okay, so just apply the formula. That's it. We proceed ahead. Prove that they are mutually perpendicular. Okay, if they are mutually perpendicular, what's going to happen? Dot product is 0. Why it is 0? Because dot product is A mod B cos theta. Now that cos theta, theta is 90. Yes, perfect. If it is clear, kindly raise your hand. Is it clear? If yes, please raise. Wish you all the best. We'll end the class and we'll do a little bit of dot product is remaining, and especially the vector product we'll be doing tomorrow. Thank you very much. Take care. Bye.
Thank you, sir.
Thank you.
So please send notes after class.